Good morning, all-star mathematicians. So today's mini lesson video, we're going to review on topics on how we can use multiplication properties to help us multiply decimals. So a quick review of the two properties that we're going to be looking at are the commutative and associative property. So you know that the commutative property has been referred to in the past as those turnaround facts. That would be that 2 times 3 we know equals 6, 3 times 2 equals 6. 10 times 5 is 50, 5 times 10 is 50. You can use the commutative property in addition and multiplication. You cannot use it for subtraction and division. But this is a key concept when we're looking at rearranging decimals to do some of the patterns as we look forward to multiplying more complex decimals. The other property that we'll be reviewing is the associative property. And the associative property just tells me when I have a multiplication expression, I can mix up my factors in any order and get the same product. I'll say that again. The associative property tells me that I can take my factors and mix them up in any order and still get the same product. Now I'll prove that to you. 6 times 2 is 12. 3 times 5 is 15. 12 times 15, I'm going to do that one along. Go ahead and do that one on the side here. 12 times 15. And 5 times 2 is 10. Carry my 1. 5 times 1 is 5. 6. Annex my 0. 1 times 2 is 2. 1 times 1 is 1. Add them up together is 180. So I did 6 times 2 is 12. 3 times 5 is 15. 12 times 15 is 180. Let's rewrite this expression to show you the power of the associative property. This time I'm going to do 3 times 2 and 5 times 6. So I rewrote those. 3 times 2, 5 times 6. If you look, I have a 3, I have a 2, I have the 5, and I have the 6. I'm just changing up the order. 3 times 2 is 6. 6 times 5 times 6, which is 5 times 6 is 30. 6 times 30. Let's go ahead and solve that one right now. 30 times 6. Put my 0. 6 times 3 is 18 is 180. That actually was easier for me to do the mental math because of my factor pairing. So the associative property talks about how you can mix those factors up, and still get the same property. So why are we talking about these multiplication properties for these decimal problems? Well, let's look at the expression 6 tenths times 9 tenths. Zoom out a little bit so you can see. You knew from the method that we did the other day, the steps would be to drop the decimal, multiply this as a normal multiplication problem, and then you need to interpret the decimal by moving it to the left, how many decimals you had in this problem. You can stick to this tried and true method as long as you would like to, but I'm going to just kind of show you some of the math behind how the associative property and the commutative property paired together can be a powerful tool for mental math. So the first step I'm going to do here is I'm going to rewrite these as fractions. We haven't done a lot of fraction to decimal work. Remember our decimal place value chart. So here is my decimal point. We would have our tenths, hundredths, and then thousandths. Let me rewrite that so it's a little bit clearer. Tenths. I'm just going to put hundredths. I'm going to abbreviate that, and then thousandths. And that would be 1/10, 1 out of 100 or 100ths, or 1 over 1,000. And this place value chart is going to help you identify the decimals to the fractions. So how can I convert those decimals to fractions? So we have 0.6. So we have my decimal point here, 0.6. I really have 6 1/10ths, or 6 over 10. Look at 9. We have 0.9 for the other number. 0.9, I don't want to confuse you by putting them together, so I'll put this one down here. There's really 9/1/10 or 9/10. So we can rewrite both of these ones, 6/10 and 9/10, as 6 over 10 or 6/10. It says the same name as that. That's why it's really important to understand and be able to name these. I'm having marker issues today. Times 9/10. All right. Well, we haven't done fraction multiplication yet, and we're not going to go there. But by using the associative property, we could simplify this expression even more to just so you understand the place value, and then you also get a good idea of how we can solve these problems mentally and check your work. So I am going to first look at how I can use the associative property with this. So I'm going to break this out. So I'm going to make this 6 times 1/10 times 9 times 1/10. What? Why are you doing that, Mr. Hoffman? Well, if you think about 6/10, right? If we drew a bar diagram, I'm going to do this on my next whiteboard. I need to just get a bigger whiteboard. 6/10 is really 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. There are 6 of those 1/10s, correct? 1, 2, 3, 4, 5, 6. So we could say that this is 1/10 added to itself 6 times, or 6 times 1/10 is repeated addition. So that's where you get the 6 times 1/10 and the 9 times 1/10. Do not allow it to cause you anxiety by looking at that and saying, what is that? Why did he do that? This is just a way to show you kind of, again, the place value and how you can use these properties. So I have now broke this apart, these 6/10, simplified it to 6 times 1/10 and 9 times 1/10. So how do I use the associative property? What I'm going to do is I'm going to pair up my non-fraction factors. I'm going to pair up my non-fraction factors. So which two would those be? That would be the 6 and the 9, and I'm going to multiply my fractions together. So I'm going to rewrite this expression as 6 times 9 times 1/10 times 1/10. Okay? Look where it was. It was 6 times 1/10 times 9 times 1/10. Now we're rewriting it to 6 times 9 times 1/10 times 1/10. Well, I know 6 times 9 is 54 times 1/10 times 1/10. Well, that might trip you up, 1/10 times 1/10. And know this, when you're multiplying fractions, you're just multiplying across. So 1 times 1 is 1. 10 times 10 is 100th. And if you think of that, if you split a tenth in two, 10 more pieces, you would have 100 total pieces. So you have 54 times 1 over 100, or 1/100th. 54, if you want to see the math, is over 1. Any whole number is over 1. So if I had 12, the fraction of that would be 12 over 1. It's just something that we assume, because 12 twelfths equals 1. 12 over 1 is 12. So what do I do next? I multiply across. 54 times 1 is 54. 100 times 1 is 100. I have 54 hundredths, or 54 over 100. Converting that to a decimal, what you could do is you could divide 54 into 100. That would be like if you were finding your percentage on a math test. Or you can just simply rewrite this knowing that this is telling me that this is 1 over 100, right? Or this is to the 100th place, 10th place, 100th place. This would be 0.10, this would be 0.100, 54 out of 100, 54 hundredths is how we would rewrite that. So today, that is one strategy that you can use to help you figure out these patterns. But say that's a lot of math and you're not ready to try that. The other thing you could do is look at just simple patterns knowing place value of decimals. So let's look at this problem, 6 times 2.6, or 6 tenths times 2, or 6 tenths times 2 tenths. I know you guys like those zeros there. I should put those zeros there. How can I complete the pattern and use that pattern to help me? Well, 6 times 2 we know is 12, right? 0.6 times 2, if I ignore the decimal, I would do 6 times 2 is 12. Count my decimals, I have 1 decimal, so I would move it from the right to the left using the method that we practiced last week and the week prior. Remember, we drop the decimal, we multiply like we would normally multiply, then we interpret by moving the decimal to the left how many decimal places we have. So we have 1 decimal place here. So let's move it to the left 1. So really we have 1.2. And then 0.6 times 0.2 would be 0.12 because we're moving that decimal 2 places from the left. So I have 12, I have 1 2 tenths, and I have 12 hundredths. When you have some of these problems and you know that you're at maybe this step, or you know this in your mind, and you need to get to this step, it's good to know the pattern and be able to analyze the pattern. So you have 12, 1.2, 0.12. All right, mathematicians, go ahead now and turn to page 201 and complete that solve and share. Do the best you can. Good luck.